Next up, we have Matt, Marcelo, and Travis from Trainline.
Yay, it's working. So, we are Matt, Marcelo, and Travis. We're from Trainline. We like to say that we are Europe's leading train and bus platform, and we help quite a big number of users every day. So we're obviously not a startup. We are quite an established company, but in a way, we do operate like a startup. We have offices here in Paris. We have offices in Edinburgh, London. We're pretty international, so we represent 3 nationalities, 3 teams, unfortunately just 1 gender. So in order to move fast, we have independent teams, and each team has different missions, meaning that our day-to-day work differs quite a lot. So we kind of have to have our own design systems. We don't have one design system for the whole company. But we do have an excellent design team of about 20 people, I think. And we kind of constantly align with each other, learn from each other, support each other, and kind of make sure that, at least from the visual side of things, things are aligned. And unfortunately, we don't share many UI components just yet. So all 3 of us help you find train tickets. So either when you are in your research phase, so when you don't know Trainline yet, either when you want to book your tickets on web, or when you downloaded our app and you just want to plan your journey there. And also, we're there to support you when you've got your tickets and you just want to go. So today, we're going to show you 3 different approaches to improving users' experience, consistency, and efficiency within teams that we represent. So I'll start with the landing pages. So this is pages that you would normally see when you don't know Trainline yet, and just try to search for anything. Then I will hand over to Marcelo, who will talk about the prototyping, the booking process. And then Travis will talk about the app and his prototyping there. So, part 1, systemizing targeted landing pages. Now, question for you, and this is also my research. How do you normally start your research? For example, if you want to go to a destination that you don't know yet, like an unknown country, for example, where do you start? Google? Okay, yeah, Google. So you would normally ask how to find cheap tickets or trains from Paris to London. So every time you do that, every time you search for something related to train or bus travel, we kind of want to attract your attention. We're kind of hoping that you will click on this link. And then we want to answer your questions that you might have and hopefully book your tickets as well. So that's my team's mission, so that I'm in the growth team. So we're covering all of Europe. We have support about 14 languages, including Mandarin and Brazilian Portuguese. And as I said, majority of people would see this when they don't know Trainline yet, when they don't know the brand. They would kind of just search for something generic, and they would see something like this. So it's really important that pages communicate things clearly and consistently. And unfortunately, in the past, to kind of target all these different keywords and situations, whatever, we had to create many very targeted applications, meaning that, well, yeah, we have about, I don't know, 20 different applications and loads of legacy systems. And achieving consistency in this world was kind of difficult. So if you're searching for a route or destination or station, whatever, these are all separate applications. This is just Europe. Then you go to UK, and you have separate applications when you want to do all of the above in the UK. So kind of bring it all together was kind of very difficult. So a year and a half ago, when we started, something like this took about 3 days of one developer. So if you want to go to all applications and just change a simple thing like a brand color, or if you want to update the station list, it took ages. So today is just a simple version bump, and I'll kind of explain how we got there. We got huge amounts of content already there. We had plenty of pages already published. They were all SEO optimized, meaning loads of text, and they weren't really engaging, so they were kind of, we could improve them basically. But we had to move really quick, so we couldn't really define a system. We couldn't spend too much time thinking about where we want to go. We literally had to ship every day because we had to grow constantly. So it was a challenge, but we kind of we got somewhere at least. So if we wanted to continue disrupting and kind of going towards being a global player in the transport space, we had to do it properly, but very quickly. So this is kind of the state of like a year and a half ago. There weren't many components shared across applications. Maybe a button, even widgets, search widgets were like, we had 5 or 6 versions. So we kind of had to simplify and optimize. So this is where we are today. So we're kind of trying to systemize as much as possible, have as little components as possible as well, and then instead do variations whenever needed. And of course, there's new data sources, there's new challenges happening every day, so we kind of have to be responsive and kind of adapt all the time. And for example, the search widget, this is one component, and we're then using variables to kind of change things. So instead of having different components that we're targeting very specific things, just have one component and then define what you want. Is it on desktop? Is it on mobile? Just make it responsive, and it kind of works. We're kind of following atomic design principles, but it's very difficult if you don't know what you actually want and where you actually want to go. So we kind of just took whatever we could, whatever was useful for us, and went from there. But still, everything is built in a way that could become an atom library later if needed. Also, we want to have same UI building blocks to be used in 2 completely separate systems, and that's automated SEO pages and CMS pages, meaning CMS pages that any content writer, for example, could just go and create a page that would answer this question in German about train travels in Europe, for example. So it was a big challenge, but once we've done that, we're able to scale really fast because we have a team of, I don't know, about 15 content writers being able to produce things really, really quickly. So they were able to do that, creating loads of pages with same components leading to same source. So every time, I don't know, a component was updated, basically the page was improved. And also this enabled content writers to create some very, very, very long SEO pages. This is half of it. This is half of it, it continues. So components like this. So this is one component. We define your variables, meaning that you upload the content once, and then you kind of iterate and you kind of go from there. So it's very easy to A/B test. It's very easy to kind of do research because you can publish pages. You can test with live pages. So no prototyping. You can just do that. Of course, this is our team, so that's a bit easier. So we were able to produce several hundreds new pages like this using standardized components. We kind of wrote design guidelines for the content team, so content writers, so they were kind of able to just take that and create pages by themselves. It's an example of an evolution of a London to Paris page, so where we were a year and a half ago and where we are today. It will continue improving. Not everything is great, of course, because we had to move super, super quickly. So we were like iterating constantly. We were messy, but still, kind of, as long as you're improving, as long as you can see like the way forward, this is kind of, it's really good. So, just a recap. So this is one single source for the team. It's one React library, meaning it can be used anywhere, like from JavaScript. You can use an application using JavaScript or C#, whatever, it's fine. Handful of components with variables, and not just that, we're kind of ready to be shared across teams because this is one team. If, for example, Marcelo's team wants to use any components here, he will be able to do that, right? And ideally, where you want to go, if this is the state tomorrow where everything is nice and organized and you have all the components and everything is kind of leading to the same source, this is one team. And then when you want to do this, and of course we don't have just 5 teams, we have way more teams, we kind of need to make sure that the structure is there. So Team 4 can take something from Team 1, and Team 1 can take something from Team 4. And it's really important to have that structure in place so we can kind of achieve that. And Marcelo?
So, hi everyone, good evening. I'm Marcelo, I'm a product designer at Trainline. So I work in the web booking flow team, and I want to talk to you about today about how we do high fidelity prototyping for web. So as Matt has mentioned today, at Trainline we tend to move quickly, we test a lot of stuff, and whatever change we make to a process has to be scalable to all the different teams, and it has to make sense within the timeframes that we work to. So, first question is, why do high fidelity prototyping in the first place? One of the reasons is that it's really difficult to validate rich concepts and ideas or features with just static prototypes. The web is a dynamic place. Like a lot of things you do on the web, you're interacting with certain components on a page and they affect other components. Yeah, so they affect other components, and it's a little bit jarring when that experience doesn't happen when you're just being tested with a static prototype. So static prototypes or click-through prototypes, they're really good for testing flows, which is basically validating whether people can get from point A to point B. But they can hide usability issues, and we've experienced that. So sometimes you ship something that you haven't actually tested, and you figure out that there are usability issues when you're A/B testing, which means you have to go all the way back into the design process and figure out another solution. So I set out to create a process that we could follow, something that was easy to maintain, flexible, and could be reusable, that we didn't have to reinvent the wheel each time. Quick, something that could have been done quickly, and that would allow us to test with super realistic interactions and states and behaviors, and would hopefully give us more accurate insights. So I started out by putting together like a compilation of every color and textile, like things that we actually use in production. So spacers and margins and paddings and border radiuses, colors, everything that I could reuse, and that was living like in a separate repository. Does anyone know CodePen, by the way? Do you? Yeah. So for those who don't know, it's like it's basically like a dev environment in your browser. So you don't have to plug anything into anything. You just load your CSS, your HTML, JS, and you're ready to go. You get previews directly on the page. You don't have to refresh. So it makes things really quick. And then I use that same library of components to create this. So that's one prototype that I created for what we call like a price capture feature. It basically means that if you're trying to purchase a combination of tickets that's more expensive than the cheapest option on the page, we'll let you know. So in this case, I'm selecting 2. The combination is 79, but there's actually a 75.20 ticket. So when you try to continue, we'll tell you, hey, you could be saving this much, and you can change directly to that. So that would have been really difficult to test without a high-fidelity prototype, so that kind of makes sense for that particular project. So I created like a little dummy feed with times, prices, durations, changes. Everything is used to populate that page, and the whole thing is dynamic. You get hover states, loading states, everything feels like the real thing. So that prototype was actually linked to from a high-fidelity prototype of the homepage. So the whole thing felt extremely realistic. So what I learned from this process is that there are a few pros and a few cons, like anything in life. It's really good because you can uncover some really hidden usability issues that you wouldn't be able to figure out otherwise. It's as real as it gets before development, so without having any dev time, and you have the skills, you could spend some time refining the responsiveness and certain aspects of the experience that you wouldn't be able to. It gives you an opportunity to refine those details, the interactions, as well as the logic. And it can be its own documentation, so you wouldn't have to spend as much time speccing things out in terms of logic or visuals. People could just inspect the code, and that's your documentation right there. And it's easy to reuse, so if you built it to some level of scalability, you could just reuse those same components. You don't have to keep rewriting them each time. Some cons, there are not many. Basically skill, and it could be yours or it could be somebody else's. Maybe you pair with a dev and get to build something. But you need time, most likely you need time. But it's a cyclical relationship, so the more time you spend refining your skill, the less time you will spend building things in the future. So some of the things I've learned with this is that it's okay if your code isn't great, as long as it works and people understand and your feature works when you test it. It's really nice if you can reuse some of the components for the next prototype, so it saves you a little bit of time. And you you will need to guide users through your test. So it's not as easy to link people to specific state in your prototype, so you have to consider that when you're doing your discussion guide. And you don't have to cover every scenario or edge case. You have to keep things very lean. It's very easy to get distracted and try to cover every single scenario, but it usually leads to a very long time developing your prototype. And high fidelity prototyping is just another tool. You have to know when to use it and when you don't need to use it. It's not like any magical formula that solves everything. So I think for me, like the next steps are basically trying to integrate the same process with our actual code base and pulling components directly from there. I started doing that with kind of like Framer X and bringing in some really basic ones, but I haven't done anything really interesting with it yet. But yeah, and I think, yeah, so now I'll hand it over to Travis. He's going to talk about some really cool stuff he's been doing for apps.
Thank you, Marcelo. Hello, everyone. So I'm Travis Hall. I work on the app team at Trainline. Today I'm going to be talking about using real data in design systems. You might have seen this earlier, but Painting with Code, Airbnb, John Gold, he's done a lot of work. This was back in 2007 about bringing React components into Sketch. This to me was like a game changer. It really changed my view on the way design systems could work, where if you directly come from the code and you can capture states, behaviors, and logic. So the way he talks about himself is instead of a series of pixels, you can have actual objects that capture the behavior and state of the component. And semantic information about what they present. So data, how they look in different scenarios can be captured in a way if you think differently to just thinking of pixels and rectangles. So this is how we currently work in Sketch. So we've got quite a good symbols library in Sketch where we have loads of components in app. A lot of our team have done a good job over the year trying to bring it together. But you tend to get this, and no matter how organized you make your system, it can get very messy. It's quite hard to understand the state of the actual component. So if a dev comes over to you and asks you, how does this look in this specific scenario, it's very hard to tell them. So when using these, this tends to happen. You detach from symbol, and you lose all that work and that information. So we've done a lot of work in Framer. The original Framer, we've done a user testing with prototypes, high fidelity prototypes, similar to Marcelo's work. And Framer X presented the great opportunity to sort of actually start building these prototypes, but reusing the components that we build. So we had three main aims: to automate the mundane, so we can spend more time solving problems. In Trainline, we have a series of results and journeys, and each one of them has a time. It's timetable information, and mocking these scenarios up takes a long time. And once you've mocked them up, you realize that you've made a mistake, or the times are wrong, the delays are wrong. So we wanted to automate that. We wanted to design real data, real scenarios, so that we could produce high fidelity prototypes for user research. So we could quickly test our assumptions, any ideas that we have. So we started with components with smarts. So this is it's quite a complex component. It's probably not our most complex. That is the ticket options. But we reproduced this into React. Framer's built on React. So we created all the different states and the properties. We didn't have to worry about the layout when we changed these states and properties because it's all Flexbox, so it's calculated automatically for you. So things move up, things move down, containers change. And then once we had this component, you could then connect it to our APIs and our JSON files. So we hook it up to our real data. This is another component, which is a list. That takes that first component. We have the options to choose a data source. For this demo, it's JSON. So we choose the file. We've got a journey response. We open it up, and we have our results. And it's just really quick then, because we can just talk to a developer or use an API and be like, okay, just give me a file. I can mock this up really quickly. I don't have to spend time nudging and moving things around. And we also have this top level search configuration so that we can just see how things look when you have a rail card. It does the calculation to, ooh, not in this prototype, but in the previous one. So now that we have that, it makes scenarios really quick to mock up. So in this case, if we wanted to see how does it look if we have delays, we can open that up and we have our delay cell. So we don't have to spend time overriding components and showing a red delay message. And then if we have just a normal response, we can hook that up and we can connect it into our actual prototype. So we have it scrollable. And then if we wanted to take it further, we could use the same concept around train stops. So your journey has a number of train stops. So we've created a train stop component and a list component that lists out all the stops. So when you do that, you get your train stops. And then changing that scenario or that journey is just a case of getting a new JSON file. And then when we bring it all together, we then have an interactive prototype which we can test with customers. If we have new features, we can add that in. And it just saves a lot of time as a design team, and it just keeps consistency. So it's first few experiments around using frameworks. It's a really new tool, and it's very complicated, but it's interesting. Final thoughts around that. So the tools aren't mature enough for production. So I would never do a project that needs to be done in 3 weeks in Framer X, because when you open that project in 3 weeks, it may break. But it's very, very promising, and it's because it's really early as a design tool. They're only 3 or 4 months out, and maybe in 6 months' time that will change. There's lots of upfront setup. So you have to create these components and you have to make decisions. Do you want this a complex component or do you want it a simple component? But the advantage of this, of setting it up like this, is you can reuse these components again and again in different scenarios, and you can create variations of them. And there's a danger of making things too complex. So anytime you start something new or create a complex component, you should question, does it need to be this complex? Or are there ways I can mock scenarios without having to do all this work? Thank you.
If you have any questions, we're still here.
Hello, good presentation, guys. Should designers code? On a more serious note, how do you manage your time while coding and designing at the same time? So do you spend more time coding or do you spend more time designing?
So I think in my personal opinion, it's always helpful if you know how to code. If you know some code, it's never going to hurt you as a designer, and you get to know almost how things are going to be built, and that actually helps you think about your solutions. But I think in my personal case, I think the more time you spend thinking about the feature, the less time you spend coding. So I see like coding should be a skill that you develop on the side, and when it's relevant, you get to use it. But the more you know what you're building, the less time you're going to spend actually playing around with code. Like you'll be more assertive, I think, more accurate.
Yeah, no, I'd agree. I don't think being able to code is a bad thing. It gives you a new perspective, especially when you work in side by side with a developer. Being able to communicate things to them in their language is really useful. Personally for me, 80% of my time is spent designing. So it's spent in Sketch. How do I automate this workflow so it can be more efficient, so I can spend more time coming up with concepts? And I think there's a lot of stuff that designers do and our tools don't really, like, say for example, John Gold, he says word processors, when you're typing, they will squiggle under a word with a red line to let you know that it's wrong, and then you can change it. And CAD programs have constraints, and they will let you know if those constraints don't don't make sense. But design tools seem to be stuck in this sort of thing, like where you can automate a lot of these problems, and that's what we should build towards. So I don't think coding is necessarily a bad thing.
Anyone else? Any other questions?
People are hungry.
Yeah. Thanks, guys.